Welcome to the 32nd lecture. We are studying AC powers. AC power is of three types: active, reactive and complex power. Before this, in our earlier course, we have studied about this DC power, which is, we write it as P, and it is the product of V multiplied by I. But here in AC, we have three different types of power because there is a concept of phase lead and phase lag between voltages and currents. So due to this phase lead and phase lag, this power is split into three parts. In our upcoming lectures, we will see reactive, we will study reactive and complex power, but today we will study active power. Active power is also called average power. This is 1 by 2 times the magnitude of V times the magnitude of I times the cause of angle between voltage and current. Any complex voltage can be written as its magnitude times its angle. Similarly, any complex I can be written as the magnitude at an angle of its current theta I. Here is an example for which we will solve this example and will find the power generated by this source, the power dissipated in this 2 ohm resistor, and the power dissipated, the active or average power dissipated in this J2 ohm inductor. First, let's find current through this series circuit. Finding current is easy, rather very easy. How would you find? The total impedance of the path is, we have two series components, 2 and J2. The impedance of the path is 2 plus J2. So the current can be computed as 10 at an angle of 60 divided by the impedance of the path. We have applied Ohm's law. According to Ohm's law, the voltage divided by the impedance is the complex current. This is 10 at an angle of 60, and we convert it into polar form. Once we do that, the answer is 2.83 at an angle of 45 degrees, which then takes us to a value 3.53 at an angle of 15 degrees amperes. So this is the current flowing through this series circuit. This means the same current flows through this 2 ohm resistor and this J2 ohm inductive reactance. Right, how would you find the power generated by this source? Since this I current also flows through this source, and we are in a very good position to find the power generated here. The power generated in source is 1 by 2 times the magnitude 10, the magnitude of current 3.53 times the cosecant of angle between V and I, 60, minus the angle of current is 15. So the answer is 12.5 volts. So this is the power generated by this source, and we must know that the power generated and the power dissipated in a circuit should be the same. The total power dissipated and the total power generated should be the same. So the power generated is 12.5. Let's see what is the power dissipated in these two circuit elements, 2 ohm resistor and a J2 ohm inductor with inductive reactance J2 ohms. So the power dissipated in resistor, we'll have to find voltage drop across it. First, let's find the voltage drop across resistor, VR. VR would be, here we have this voltage, the voltage drop across 2 ohm resistor can be computed using voltage divider theorem times 10 at an angle of 60. So this is 2 plus J2 we have just computed. This is 2.83 at an angle of 45 times 10 at an angle of 60. So this gives us a VR equal to 7.07 at an angle of 15. Now we can compute PR, which is 1 by 2 Vm Im cosecant of theta V minus theta I. The voltage drop across resistor, the magnitude of that value is 7.07. The current we computed is 3.53 at an angle of 15. So the current is 3.53 cosecant of theta V, which is 15 minus 15. 15 minus 15. 15 minus 15 means 0. So cos of 0 is a 1. And the answer is 12.5 watt. And the last thing to compute is the power dissipated in this inductor having inductive reactance J2 ohms. That would be, to find that, first find VL, the voltage drop across inductor according to VDR, voltage divider theorem. This is J2 divided by the sum times the total voltage 10 at an angle of 60. This gives us a VL equal to, what is VL? VL is equal to 20 divided by 2.83. You can divide the two and find the final answer at an angle of 105 degrees. So what we are required to do now is to compute the power. Power in the inductor would be 1 by 2 times VL, which is 20 divided by 2.83, the magnitude times the magnitude of current, the same current flowing through every component. It's a series circuit. The current is 3.53 cosecant of the angle. The angle is 105 minus the angle of current is 15. So 105 minus 15, this is cos of 90, and we know cos of 90 is a 0. So the power dissipated in inductor is 0, and you should not be amazed because the active power dissipated in inductors and capacitors is always 0. So power generated by the source is 12.5 watt. Power dissipated in resistor is 12.5 watt, and the power dissipated in inductor is 0 watt. So the sum of these two is 12.5 watt. So the power generated in the source is the same as the power dissipated, but the active power dissipation would always be 0 for inductors and capacitors. For inductors and capacitors, we have other non-zero power, we call it reactive power, and we'll study this reactive power and the complex power in our upcoming lectures. Thank you.